Alright, so we're doing continuous marshmallow processing, and my name is Evan Staten.
I'm Danica Weiland. Deanna Esposito. Chelsea Barrett.
Alright, so the objective of this project is we want to design a continuous process to produce marshmallows. We want to minimize process inefficiencies, reuse resources throughout the process, and we need a production rate of 500 pounds per hour. We worked with Chicago Vegan Foods, and that's kind of what they wanted to upscale. And the process is intended for a vegan marshmallow processing. So during our background review, we got a lot of our resources by Jamak, and he actually invented the process of making marshmallows how it is today. He's the founder of one of the biggest marshmallow companies out today. So America can spend over $150 million on marshmallows, so there's a market out there for more product to be made. And actually the number of vegans in the last 3 years has more than doubled, going from 3 million to over 7 million. So there's a lot of a need for more marshmallows, and there's a greater amount of vegans out there.
As Evan says, we are designing a process to produce 500 pounds an hour. So in order to determine the equipment to produce continuously, we needed to determine the mass balance on each stream. So by using the compositions of each stream, we worked backwards from 500 pounds an hour to determine the flow rates for each equipment. And using these flow rates, we designed our equipment and found the energy balance on each equipment in order to determine the total energy requirements for the system. There are two mixers involved. One is heated and one is not. The not heated mixer has been designed with a volume of 0.75 meters cubed with an agitation speed of 50 RPM. And the heated mix exchanger has been designed as a shell and tube, and the heating begins 3/4 of the way down the heat exchanger in order to allow for proper mixing before heating begins. The overall length is 9 meters, and the heat exchanging length is about 6.7 meters. And the inner diameter is 0.03 meters with an outer diameter of 0.03 meters. So the innovative part about our process is that every piece of equipment connects and it's continuous, instead of making something in batch and then taking it out, cleaning it. So from what Danny explained, she designed this heat exchanger, and then I designed the recycling heat exchanger. So normally when you make marshmallows, you mix all the ingredients, you heat it up, and then you cool it down. So instead of using water to cool it and steam to heat it from like one temperature to another, we actually use the product to recycle back and heat itself up and cool itself down. So that's what you can see here. This is the only water to cool, and this is the steam to heat, and all the stuff in green is recycled. So you can see, after doing calculations, it's a savings of just over $3,500 per year, and that's just basically the cost to heat and the cost of power. So from there, it goes into a whipper/aerator. So there are a couple ways to do this. When you're making marshmallows at home, you use a hand mixer. That's how you get the air incorporated. But for us, we're actually going to inject air, and since it's a continuous process, we got to make sure it's a turbulent flow to get everything all mixed up and the air incorporated in there. So we designed that piece of equipment, and then finally it goes into an extruder, which is not an extruder that would make marshmallow like cereal at high pressure. It's kind of a lower pressure extruder, and so it basically just extrudes the marshmallow out, and then it'll be chopped up into pieces and go into packaging.
And we also looked at various alternative solutions. So some of our alternative solutions would be different ingredients that we could use, different pieces of equipment we might implement, and then a different process in order to heat and cool our product. In addition, we looked at how we can make our process more sustainable. We focused on using water recovery and water reuse. So looking at condensate recovery, cascading, and the use of filters in order to make sure that our water is clean and reusable for our process. And then our social and global impact is that we'll be creating a product for vegans to help them support their lifestyle and their ethical choices.
So why are traditional marshmallows not vegan, and what's the challenge in making a vegan-friendly marshmallow?
Traditional marshmallows are made with a gelatin that comes from animals, whereas vegan marshmallows would need a gelatin that does not come from animals. So this could be something like carrageenan. And in processing, you need to make sure that the equipment used to produce these marshmallows has not previously previously been used to produce anything that has any animal or milk or egg related products that have passed through it. So that is one challenge to consider when producing a vegan product.